Day 8 was another really tough puzzle for me, almost too hard for me to figure out, but I'm really happy I managed to come up with a solution in the end. Maybe not the best or prettiest solution, but a solution nonetheless. Today's input is a two-dimensional grid of numbers between 0 and 9. We're asked to imagine that we're looking down at a large field of trees where each number is a tree and the number itself represents the height of that tree. Our first task is to figure out how many trees have a clear line of view in at least one direction, up, down, left, or right. A tree has a clear line of view if it's on the edge of the grid or if it can see over all of the trees in at least one direction. For example, take the second number on the second row, number 5. It has a clear line of view both up and left, so this will count. But the number 1 on the same row will not count as it is blocked by at least one larger number in every direction. My thinking here is to go over each line and on each line go over each number or tree. Then somewhere in that loop over each tree, figure out if the tree has a clear line of sight. I start by filtering out the edges. So if the number is on the first or last row or column, I increase a number that I call sum and move on. But for numbers not on the edge, things got difficult. For every number, I somehow need to gather the 4 other lists of numbers, the ones to the left, right, above, and below the number we're checking. I went back and forth with this for about an hour until my brain started to melt and I was ready to give up. I needed a break and coffee. But once caffeinated, I sat down with the problem again and was finally able to come up with a solution. Let's fast forward a couple of hours. All the way to my solution for day 8, part 1. Now, to get the trees to the left and the right of the one that we're currently on, I could just use our current row. To get the left side, I slice the row from the start up until the column that we're currently working with. I then use mathmax to end up with the largest number to the left of the current tree. I do the same thing for the right side, only now I slice from the column that we're currently on, +1, to the end of the row. For the columns, I ended up looping over every row once again and pushing the tree in our current column into a new array. With that new column array, I then use the same method as before, getting the largest number above and below our current tree. Lastly, I check if our tree is larger than any of these numbers, and if it is, I increase the sum. Running the script gives us 1851, which turned out to be the right answer. For part 2, we need to figure out every tree's scenic score, which we can get by multiplying together its viewing distance. And a viewing distance in one direction is how many trees it can see over. So how many steps until it encounters a tree that is as large or larger than itself. Take that distance in each direction, multiply it together, there's your scenic score. The task, what is the highest scenic score possible? We repeat the code from part 1 to save all the trees in all 4 directions. Only now we save the whole array, not just the highest number. We also need to reverse the left and the top array, since when we're going over these, we always want to move from the current tree and outwards. We go through each of the 4 direction arrays one by one, and in each we check if the current number is equal to or higher than our current tree, or if it's the end of the array, which means that the tree can see all the way over the edge. Once a tree is found, we save that index +1 in our scores array. Then we use reduce to multiply these scores together to get our scenic score. Lastly, we make sure to keep track of our highest scenic score in the best view variable. Running the script tells us that the largest scenic score is over 500,000, which is huge, and also happens to be the right answer. Very nice. Today was exhausting, and I'm not sure how many more of these days I'll be able to do. But if we end here at 16 stars, I'm going to be happy. If you enjoyed this video, please hit the like button. And if you're participating in Advent of Code as well, please let me know in the comments below. That's it from me today. Thank you for watching. Ciao.